So here is a second bonus for elimination reactions. It's called Bredt's rule, and we have dicyclic molecules like this one. Now, how do we know this is going to be an elimination reaction? Well, first we notice that we have a strong base and strong nucleophile, sodium hydroxide. We notice that we have a secondary carbon with our leaving group, which is bromine in the situation, and the neighbor is a tertiary carbon, so that forces it to favor elimination over substitution. And so it's going to be an elimination reaction. Now, knowing that sodium hydroxide is an unhindered base, by Zaitsev's rule, we're going to have an elimination reaction with the hydrogen that is on the most substituted carbon, which would be this carbon. Now, however, according to Bredt's rule, we cannot have double bonds on a bridgehead carbons. So the bridgehead carbons are these carbons right here. I'll label them with red circles. These are bridgehead carbons. We are not allowed to have double bonds on those carbons. That's just Bredt's rule for you. Now, another thing about dicyclic molecules, what's special, is that in elimination reactions, while we normally have anti-coplanar hydrogens, we don't have any anti-coplanar hydrogens in this situation, whether it be this hydrogen or this hydrogen or this one. We cannot get anti-coplanar hydrogens because this molecule is very rigid. And so, let me just label that. So, we have something called syn-coplanar. And so, what ends up happening is that we end up taking the syn-coplanar hydrogen, the one that's on the same plane as bromine. And once these two go away, we get this molecule right here, where we have our bridgehead has not changed. We now have a new double bond that forms right here. The bottom hydrogen that was facing downwards, which is actually called the endo position, is not changed. And this hydrogen that's also endo is not changed. This hydrogen back here has not moved at all because we cannot have a double bond with our bridgehead carbon. And our bridgehead carbons have remained the same. So this is Bredt's rule. Just to reiterate, you cannot have double bonds over here. That is not allowed. And we have a syn-coplanar elimination reaction where the hydrogen that's syn on the same plane as bromine on the same side is going to happen. So for example, this hydrogen right here will not be taken out, but rather this hydrogen right here.